A Campi Flegrei Vesuvius link confirmed. Once a fringe hypothesis, now a finding reshaping how scientists assess volcanic risk beneath southern Italy. Beneath the densely populated landscape surrounding Naples, a profound revelation has emerged. One that has unsettled researchers and the more than 3 million people living in the shadow of two of Europe's most dangerous volcanoes. For generations, Campi Flegrei and Mount Vesuvius were treated as separate threats. Different plumbing, different magma reservoirs, different eruption scenarios. That assumption is now under serious strain. In 2024 to 2025, new high-resolution seismic tomography, gravity anomaly mapping, and geochemical fingerprinting revealed evidence of an approximately 9-kilometer-long subsurface zone connecting the two volcanic systems. Rather than a single open tunnel of molten rock, scientists describe it as a corridor of mechanically weakened, partially molten crust, a zone capable of transmitting heat, pressure, and magmatic fluids. This matters because both volcanoes sit within the same regional stress field of the Campanian Plain, one of the most volcanically complex zones in Europe. Key findings include overlapping helium isotope ratios, 3He/4He, in gases released at both systems, indicating a shared deep mantle source. Seismic velocity anomalies.
From Seth Doan in Italy, some notes from the underground.
The displays at this nerve center may rattle a few as they monitor the increasing volcanic activity around Naples, Italy,
Suggesting low rigidity rock between reservoirs. Correlated uplift and subsidence signals detected by INSAR satellites. At Campi Flegrei alone, the ground has uplifted over 1.2 meters since 2005, with more than 20 centimeters since 2022, accompanied by thousands of earthquakes per year, including swarms exceeding 600 events per month during peaks of unrest. Vesuvius, though quieter at the surface, shows persistent deep seismicity and thermal anomalies consistent with ongoing magma recharge at depths of 8 to 12 kilometers. Historically, volcanic hazard models assumed independence. Campi Flegrei equals caldera-style unrest, deformation-driven crises. Vesuvius equals explosive stratovolcano with long repose periods. But modeling shows that pressure changes as small as 1 to 5 megapascals, well within the range produced by magma ascent or degassing, can propagate through weakened crustal zones over distances of 10 kilometers or more. In practical terms, increased pressure beneath Campi Flegrei could destabilize magma storage beneath Vesuvius. Degassing or intrusion at Vesuvius could alter stress conditions inside the caldera. Seismic swarms may no longer be strictly local signals. This does not mean a joint eruption is imminent, but it does mean interaction is physically plausible, a significant shift from decades of planning assumptions. The stakes are immense. 500,000 people live directly within Campi Flegrei's caldera. Approximately 700,000 people reside in Vesuvius's red zone. The greater Naples metro area exceeds 3 million residents. Campi Flegrei's last major eruption, the Campanian ignimbrite, approximately 39,000 years ago, was one of the largest in Europe's geological record. While such an event is exceedingly unlikely today, even moderate eruptions could force evacuations on a scale unmatched in modern Europe. Vesuvius's AD 79 eruption killed an estimated 16,000 people, despite a population density far lower than today's. Modern Naples is denser, faster moving, and more fragile. Italian authorities already operate one of the most sophisticated volcanic monitoring networks on Earth. Hundreds of seismic stations, continuous gas monitoring, real-time satellite deformation tracking. But a connected system demands a connected response. Scientists are now debating whether alert levels should be evaluated jointly, whether evacuation thresholds need revision, how to interpret seismic signals that may propagate between systems. As one volcanologist summarized, we are no longer watching two volcanoes. We are watching a regional engine. When the ground beneath Naples speaks, it has always demanded attention. What has changed is how many voices may now be speaking through the same structure. Not two isolated systems, not neatly separated risks, but a shared subsurface environment, slowly deforming, quietly pressurizing, and reminding scientists that volcanic systems do not respect the boundaries drawn on maps. The discovery of this 9-kilometer connection does not predict disaster, but it redefines vigilance. And it raises a question as old as Vesuvius itself. If the giants beneath Naples are linked, who can truly say where the next warning will begin, or how far its consequences will travel? Warnings have accumulated for years, as Campi Flegrei, in particular, has begun to stir in ways not seen for decades. On March 13, 2025, a magnitude 4.4 earthquake, the most powerful at Campi Flegrei in over 40 years, rattled Pozzuoli, a town of 80,000 perched over the caldera's restless ground. Residents fled their homes amid breaking glass and shrieking alarms. Emergency lines were quickly overwhelmed by reports of cracks opening in streets and buildings, sometimes venting steam. This spate of fissures and the alignment of subterranean quakes soon led geologists to re-examine the underlying structure of the region. These cracks often followed a deep geological line trending toward Mount Vesuvius. Seismic analysis, including advanced AI interpretation of quake records, revealed tens of thousands of microtremors, the kind that would otherwise elude standard measurement, suggesting immense stress spreading through a rock corridor some 9 kilometers in length between the two volcanoes. Within days, seismic monitoring stations at Vesuvius, mostly quiet since 1944, detected deep tremors echoing those at Campi Flegrei. Simultaneously, new steam vents appeared across both volcanic fields, and atmospheric sensors picked up increased levels of magmatic gases, particularly the sulfurous compounds that rise from deep beneath the surface. For the first time, a clear chemical fingerprint linked the renewed activity at both sites. Taken together, these warnings have shifted the discussion. Some experts now say that if one volcano erupts, it could increase the likelihood of unrest, or worse, at its neighbor. The consequences would ripple far beyond Naples. So, what do we really know? And how much time do we have? Understanding Campi Flegrei requires looking down through tens of thousands of years of history. Campi Flegrei, literally burning fields, spans 8 miles and has been the site of some of the largest eruptions in Europe. This caldera doesn't rise above the landscape in a classic cone, but is instead marked by a field of vents, fumaroles, and bubbling thermal pools distributed across the suburbs of Naples. Its threat is subtle, but immense. Roughly 39,000 years ago, the Campanian ignimbrite eruption unleashed over 200 cubic kilometers of ash and rock, in an event that may have helped plunge Europe into a volcanic winter. About 15,000 years ago, the Neapolitan yellow tuff eruption further shaped the current caldera near today's city. Human settlements here have always lived with the ground's restless rhythms, uplift and subsidence cycles so characteristic that scientists coined the term bradyseism to describe them. For the last 75 years, Campi Flegrei has been stirring. The ground has uplifted by more than 4 meters since 1950, and in recent years, alarming scientists, the pace has quickened, reaching 2 centimeters per month since 2025. This is more than 3 times the rate seen in earlier episodes. As the land lifts, Roman ruins in Pozzuoli and along the old harbour have gradually disappeared beneath the rising sea, hinting at the steady underground buildup.
Seismic swarms are occurring. In the early 1980s, over 16,000 earthquakes rocked the area in 2 years, damaging buildings, releasing foul-smelling gases, and driving tens of thousands of people from their homes. Each subsequent episode of unrest escalates the urgency, squeezing the margin for error smaller each time. Until recently, disaster response plans focused on a single volcano at a time. This new evidence suggests those plans may need to change. Vesuvius stirs, awakened by an ancient partner. Mount Vesuvius looms just beyond Naples, its profile familiar across the city. In AD 79, Vesuvius's cataclysmic eruption buried towns in minutes,
a story carved into memory by the ruins of Pompeii and Herculaneum, and retold in classrooms around the world. Structurally, Vesuvius is a somma stratovolcano, a steep-sided peak with a complex inner history less than 10 kilometers from Campi Flegrei. Its last eruption was in 1944, after which it fell quiet. This silence, however, was always regarded as temporary. Monitor readings after Campi Flegrei's March 2025 earthquake tell a new story. Deep tremors, absent for over 8 decades, began rumbling beneath Vesuvius. These were no mere surface shakes, but signals suggesting internal pressure changes. Venting increased on the slopes of both volcanoes, with sulfur-rich gases giving scientific teams even more reason for concern. Thermal satellite images detected an anomalous zone of heat, a signature that aligns with a supposed 9-kilometer corridor beneath Naples. Although the specifics of how heat and magmatic material might flow between these two systems are still being studied, the data increasingly support the idea that the area's volcanism cannot be understood in isolation. The Italian government has raised monitoring levels, while scientists and planners confront an alarming scenario. A disturbance at one volcano could potentially have consequences for the other. While direct, synchronized eruptions remain unproven and rare even in the annals of volcanic activity, the increasing interconnectedness raises dire questions for evacuation planning and hazard modeling. Inside the 9-kilometer magma highway, evidence mounts. What is really happening underground? Advances in seismic imaging, satellite data, and gas chemistry have accelerated our knowledge. After the March earthquake, seismic tomography, akin to taking a 3-dimensional X-ray through the Earth, revealed a softened, possibly semi-molten body or conduit linking the two volcanoes. While not a direct gushing channel of magma, this feature could allow the transfer of heat, fluids, and perhaps pressure between Campi Flegrei and Vesuvius. Such structures were assumed to exist only in geological fiction, but measurements in 2025 have given them a place on scientific maps. Thermal monitoring detected spikes in ground temperature along the corridor, over 12 degrees Celsius higher than normal. At the surface, dormant steam vents awakened in both volcanic fields, and gas samples indicated new influxes of deep-origin sulfur. These patterns, synchronous on both flanks of Naples, have dramatically shifted the conversation. Scientists now talk openly of an evolving system in which disturbance at one end could propagate to the other. Satellite interferometry tracked the swelling ground, showing uplift at Campi Flegrei mirrored by subtle but real changes at Vesuvius. The shared source hypothesis, a large, deep magma lens feeding both, gained traction in response to this synchronized behavior. As one volcanologist put it, we are seeing phenomena that challenge the boundaries we thought existed in the Campanian volcanic arc. Naples is a metropolis of more than 3.5 million people, Europe's largest city in a volcanic hazard zone. Life continues with apparent normalcy, but new cracks appear each morning in houses, streets, and sidewalks. In Pozzuoli, wisps of steam drift across playgrounds. The scent of sulfur often rides the wind into kitchens, schools, and subway stations. Hospitals report increases in respiratory complaints, possibly related to intermittent spikes in sulfur and particulate matter. Emergency services keep busy responding to tremors and land movement complaints, now routine in some neighborhoods.
The risks are not just geological. Civil defense officials face logistical nightmares, knowing that evacuation plans for Campi Flegrei and Vesuvius would converge on the same limited set of roads. In drills, even serious alert scenarios result in gridlock projections within the first hour. The city's proximity to the coast further complicates matters. There's simply no easy escape for millions of people if events escalate quickly. Satellite modeling suggests a dual eruption could darken skies across much of southern Europe, disrupt international air traffic, and bury agricultural lands beneath thick ash. Economically and socially, the repercussions would stretch far beyond Naples or even Italy. The threat beneath Naples is measured in 4 clear, escalating signals. First is ground uplift. 75 years of data show more than 4 meters of vertical movement, but the current pace, 2 centimeters per month, terrifies experts. This uplift is a sign of accumulating pressure, rarely witnessed at this rate anywhere else in the world.
Second is the composition of volcanic gases. Gas emissions, especially sulfur dioxide and hydrogen sulfide, are rising. These compounds suggest new magmatic material is making its way closer to the surface, feeding both volcanoes' systems. Atmospheric readings recorded noticeably higher sulfur levels after the spring 2025 unrest. Third is seismicity. Over 210 earthquakes rattled Campi Flegrei in a short period during the March 2025 swarm. AI-assisted interpretation uncovered the presence of more than 50,000 microtremors, signatures of shifting, tearing rock at depth. Each small quake provides another hint that the system is changing, not stabilizing. Fourth is the apparent growth of the underground corridor. Thermal imagery and seismic mapping indicate an active, dynamic structure is evolving between the two volcanoes, with each new fracture or heat spike broadening the path for pressure and fluids. These signals have reset the agenda for scientists and emergency planners alike. Now, attention has shifted from whether either volcano will erupt to when, and whether their interconnectedness could turn a crisis into a catastrophe, impacting not just Naples, but the wider region. The Mediterranean is laced with volcanic arcs and calderas, most prominently in southern Italy and across the sea in the Greek islands. While historically these volcanoes were viewed as geologically separate, growing evidence shows the region's magmatic plumbing is complex and potentially interconnected. Mount Etna and Stromboli, both among Europe's most active volcanoes, lie to the south and east. Farther still, Santorini's partially submerged caldera is a grim monument to eruptions that shaped civilizations long gone. While there is no direct proof that a disturbance at Campi Flegrei or Vesuvius would set off a chain reaction across these distant calderas, the geological architecture beneath the Mediterranean basin is less isolated than once thought. Disaster planners in Rome, Paris, and Brussels are factoring coordinated volcanic events into their risk matrices, not as inevitabilities, but as plausible scenarios for which continent-spanning evacuation and aid plans may one day be necessary. New research is expanding the scope of hazard models, recognizing that the mixing of magmatic material and pressure in one site may have unpredictable ripple effects across the arc. The world's top volcanologists have converged on Naples in recent months. They bring advanced seismic arrays, drones, thermal imaging equipment, and powerful computers running AI-driven prediction models. And yet, every new dataset reveals more to worry about. The land continues to rise, microtremors do not abate, and gas emissions keep surging. Every day, researchers patrol the streets of Pozzuoli and surrounding neighborhoods, measuring fissures and checking for new hotspots. Satellites provide overhead confirmation, a fresh emission, a deep plume of steam, adding to a growing body of evidence that the status quo beneath Naples is gone. Civil planners simulate evacuation routes, test medical surge capacities, and game out scenarios for ash dispersal over Europe. The results are sobering. If both volcanoes erupt in close succession, normal emergency response plans will quickly prove inadequate.
Residents are adapting as best they can. Children in schools now practice evacuation drills regularly.
Households keep bottled water, spare food, and, increasingly, masks on hand. Church bells ring for mild tremors, their meaning well understood by everyone within earshot. In City Hall meetings, scientists present monitoring updates, indicating that the underlying corridor between the volcanoes continues to widen and intensify with time. Local governments work closely with civil protection agencies, coordinating with European Union assistance programs to prepare for worst-case scenarios. But everyone, from city officials to international scientists, agrees that the deeper processes underway cannot be stopped by human intervention. At best, the hope is for timely warning and efficient evacuation in the event of eruption. Naples, its suburbs, and the entire Campanian region now exist in a tense and unfamiliar reality, waiting for clearer answers that may never come. Ground heating, seismic activity, gas emission patterns, and satellite images all point to an accelerating situation. In Pozzuoli, older residents remember previous crises and wonder how this one differs. Newer generations watch as their world changes, learning seismic science in childhood and keeping emergency kits at the ready. Every week brings new data, more cracks in buildings and roads, more gas alarms, and continued minor tremors. Emergency volunteers knock on doors distributing information and supplies. City planners update contingency plans, striving to keep pace with geological developments happening beneath their feet. Above all, a sense of anxious anticipation pervades. Each morning, as residents look toward the silhouettes of Campi Flegrei and Vesuvius, they are reminded that the fate of Naples, and perhaps much more, hinges on the ever-changing conditions beneath them. Monitoring does not pause. Satellites circle overhead, observing new plumes and ground deformations. Volcanologists analyze every spike, every emission, every slight uplift, looking for a precursor that might provide more than hours or days of warning. All know that while the new subterranean corridor between the volcanoes has been mapped and measured, the timeline for what comes next remains stubbornly uncertain. The people of Naples, their scientists, and their leaders are united by a single question echoing in countless forms. How close are we to a moment of reckoning when ancient forces once divided might act together? The separation is gone, the connection beneath Naples has been revealed, and the urgency in monitoring and planning has never been greater. All who live here, and many far beyond, await the next sign from below, hoping for time, fearing for what may come, and adapting to life on the restless edge of the unknown.